So, when we have fractions, remember, we can break down fractions into their prime factors. Like 20 is made up of 4 times 5, and 4 is 2 times 2. Right? 2 times 2 times 5, 24. And then we cross-cancel common factors. When I'm cross-canceling, this is 10-1, by the way, 10-1. When I'm cross-canceling, okay, when I cross-cancel, what is left when I cancel them?
5,
No, a 1 here. Doesn't mean nothing's left, okay? Because if you get rid of everything, what are you going to put? Over 1, or 1 on top. Do you understand what I'm saying? So then when we finish, we'll end up with 5/6. Now, so if I have something like this, I can expand it out again, the same way, into common factors. Into common factors. And if I'm doing that, you can see, but this is going to take us too long, right? It's taking us too long. And then I'd be left with an a squared, and in the denominator, a 7 and a b, right? So instead of expanding out, you should be able to just look at it and first say, numerically, what's the greatest common factor?
5.
A 5. So I divide out of 5, I'm left with 1. I divide out of 5, I'm left with 7. What's the greatest amount of a's we can divide out?
1.
I can take 1a out of the top, and I'm left with a squared, and 1a, divide 1a out, and I'm left with the number 1. Okay? And then, what's the greatest amount of b's?
2.
I can take a b squared out, and I'm left with the number 1. And down below, I'm left with b. And so, in the numerator, I'm left with a squared over 7b. Are you guys with me? All right, so I don't mean to cut you off, but that's where we're at. So, basically, we're just reducing by knocking out common factors. Okay, so I'd like you to do that same thing on number 1. Just do number 1. Pause the recording. And so what is common numerical factor we can divide out? Ethan?
2.
A 2, and we're left with a
3
over
of 5.
Good. And what's the greatest amount of x's we can divide out? Ava?
1.
I can take 1x out. What's left in the numerator? X. And in the denominator? 1. And what about the greatest amount of y's?
You can take out 1 y,
And what's left in the numerator?
y cubed.
And in the denominator? 1. So my final answer is 3xy cubed over 5. Now what we're dividing out there are called monomials. They're single terms, right? These are monomial divided by monomial. Now if we look at number 2, it's a binomial. So let's pretend the bottom is not there. What can we do with this binomial 5x plus 10? Yes, Alejandro.
Factor out 5.
Factor the 5. So when I do that, I'm left with 5 times x plus 2. All over x plus 2. Now what do you think we do? Ava? We're going to cross-cancel or simplify, reduce the x plus 2 factor. And so what would be left? 5. 5 over 1, and we don't need to write over 1. Yes, question.
If you do it, could you do it like this? So say the x and the 5x, could you say, because there's, cross that
We
out.
cannot do this. Listen, you may not take a piece of a binomial. That's why you must factor it, because when you cross-cancel, you cannot take a piece of a binomial. I cannot do that. I cannot do this. Do not try and do that. Do you understand? Okay? It has to be binomial divided by binomial has to look exactly the same. So we factor first, and then we list what's left. Okay, so now here's why. Here's why. If I can't take an x out, just look up here. You don't need to write this down. This is just an example of why. Let's take the first one. If I put a 4 in there, what is it simplified to? Is there a factor of 3 in that 7? No, there's no factor of 3 and 7. But if I add, let's say, again, I make x 4. In this situation, that multiplies to 12. Is there a factor of 3 and 12?
Yes.
Yes. So when there's the plus sign, we don't necessarily have the factor in there. Do you understand?
Yes.
Okay. So now let's break down. I want you to factor the numerator, factor the denominator, and then cross cancel. Do the same thing with number 2. Don't forget your GCFs. Pause the recording and simplify 1 and 2. What does the numerator factor out to, Melanie?
X plus 5 over 5.
No, the numerator factors out to
X plus 5, X minus 5.
x plus 5, x minus 5. Denominator, quickly.
5 times the quantity of X minus 5.
Good. So now what can we simplify? What can we cross cancel, Emily?
You can cross cancel the x.
I can't just take a piece of a binomial. X minus 5s. And notice I want to see that line there. So what's left is x plus 5 over 5. Can I then cross cancel the 5s? No, I can't take a piece of a binomial. Okay, next one. Ava, factor the numerator.
3 times X squared minus 9.
3 times x squared minus 9, which again breaks down to what? 3 times?
X plus 3 times X minus 3.
Good. And then the denominator breaks down to what?
Minus 7 times X plus 3.
Times x plus 3.
And cross out the X plus 3.
And we are left with 3 over x minus 3 all over x minus 7. Are you with me? Yeah.
You don't distribute it.
No, do not distribute it. I want it in factors. I want to see the factors. It makes it easier for me to check it. Okay. Yes, question. Toggenberger. Oh, yes, you may go. Sure. Okay, so let's take a minute. Oh, he's going to miss factoring opposites. Okay. Dariush, explain it to him afterwards. Okay, so what is the opposite of if I have a factor of 7? What's the opposite? Good. What's the opposite of y? Good. What about the opposite of x plus 3? Negative x, negative 3. Okay, what about the opposite of y minus 8? Negative y plus 8, but can't we just write that 8 minus y? To flip it around, I could do that, and right, because it makes it negative y. It is a negative y. I'm just not listing my negative first, right? So how would I do it that same way given 2x minus 3, raising a quiet hand? Aaliyah, what would the opposite be?
3 minus 2X.
Perfect. Okay, what would the opposite be of 6 minus 5x? Let's go with Jake.
5X minus 6.
5x minus 6. Okay. Next, what would I do with t minus 8? The opposite. Thank you. T minus 8. Ethan.
8 minus t.
Perfect. Okay, now we're going to do something else. We are rewriting as a product of negative 1 and its opposite. So negative 1 and the opposite of negative m is what? M times m. Now, is that equivalent to what's seen there?
Yeah.
So when you multiply negative 1 times the opposite, it makes an equivalent expression. So how would I write number 2? Ethan?
Negative 1 times negative d.
Yep. And that equals positive d. What would we do for number 3? Number 3, Charlie.
Negative 1 times the quantity of x plus 4.
Yep. What are we doing for number 4? Negative 1 times, go.
3 minus.
3 minus b. Right? Kayla, what's the next one going to be? Negative 1 times.
Negative 1 times the quantity of negative 2x plus 5.
We turn it around. 5 minus 2x. We put the negative second. Django.
-1 times the quantity of 1 minus x squared.
Good. Next one, go. Nell.
-1 times y minus 6.
Good. Next one, Sadie.
-1 times 7k squared minus 3.
Perfect. You guys get the idea? Now, here's where we're going to use that. Ready? So now we're simplifying a fraction. How does the numerator break down? Write this down. How does the numerator break down, Yaakov?
It breaks down x plus 3 and x minus 3.
Oops, I forgot my x. Okay. Okay. And then notice we have a 3 minus x. So what can I do? Yes.
Do -1 times x minus 3.
I'm going to do a -1 times the opposite, which would be x minus 3.
You could just do that.
Yeah, isn't that equivalent to that?
Yeah.
Aren't they equal?
Can we just write?
And so now what that allows us to do is cross cancel.
Put on the 1.
Leave it. X plus 3 over -1. And notice I have equals, well, I mean, I guess you should do it stacked on top of each other. It's not really a run-on equation. It's not an equation. We're just simplifying right now. Now, you could write it like that, or I could take the -1. Remember, only with -1 can you do this, x plus 3. Or I can divide them both out, and I can do -x minus 3. All of these are the same. I personally would like you to stop here. But I would mark all of these correct. Does that make sense?
Yeah.
Okay, so try the next one. Pause the recording and do number 2. Okay, in the numerator, what multiplies to -30 and adds to -1? Yep. -6, +5, so it's n minus 6. And the other one is 6 plus n over 6 minus n. But now we can do what? Factor out a -1 in the numerator or denominator. It doesn't matter. If I do it in the, let's see where my PowerPoint did it. If I do it in the denominator, I'm flipping. Notice how I put it all the way to the left. Are you with me?
Yeah, none of them cancel, then you should factor out
If they seem like opposites, look. When do I do this, Django? Notice I have an n minus 6 and I have a 6 minus n. They're exactly opposite. So when I pull out the -1 out of here, I just put it here, but it makes this become the opposite.
So then you can cancel.
And now we can cancel them, and now we're left with n plus 5 over 6 plus n, -1 times 6 plus n, right? No. Yeah, you could. You could just leave it there.
Oh, don't.
Yeah, you can leave it or you can multiply it out. Doesn't matter. Okay. All right. The next ones we're going to go through quickly and we're going to do it together. So now here we're just going to have more complicated factoring. What multiplies to -6 and adds to 1? What?
No.
Oh, no, positive one. Yeah,
-6. No. -3.
-2 and 3.
+2.
And -3.
Yeah. So we get x squared. Let's just do this. X squared. Oh, sorry.
Don't you have to divide it by 2 again?
Hold on. Let me write. Sorry. Okay. So I'm getting x squared plus x minus 3 factors 2. Oh, sorry. Plus 6. Right? Minus 6. So I get x minus 2 times x plus 3. And then we have to divide by 2. Divide by 2. We get x plus 1. And we get 2x plus 3. So our numerator becomes 2.
X plus 1.
Our numerator becomes 2x plus 3 times x plus 1. You guys with me? Okay. Now, the denominator is 1 plus x and 1 minus x. Oh, whoops, it should be here. I'm sorry. I made a mistake here. X minus 1, right? Is that what you meant?
Yes, that's what I meant.
Sorry. Okay, x minus 1. Okay. And it should be, sorry, I screwed that up. X minus 1. And down here, we're going to have an x plus 1. Why am I just a disaster here? X minus 1, okay? So x minus 1. Now, these are opposites, so we can divide a negative 1 out, right? Out of the denominator, and it will flip it around to, oh, this time they divided out of the numerator. Are you guys with me? Okay. And so we are left with negative 1 times 2x plus 3 over 1 plus x. Okay. Do not multiply that back in. So the question is, do we have to factor out that negative 1, or it would stay the same? We won't be simplifying. Now, don't forget, you're going to have GCFs. So the GCF in the top one is a 2x, and then we're left with x squared. In the denominator, I have a 10x. And then we are left with a difference of squares in the numerator. Right? We have to factor that out. And then we can just factor out the x minus 10. And what else? What else can be simplified or reduced? The 2 and the 10. 2 goes into 2 once and into 10. And the x. How about just the x outside of the monomial x?
The x minus 10 and x
No,
minus 10.
the x and the x. I already said the x minus 10.
Okay.
So don't forget that other x there. So our answer is x plus 10 over negative 5.
They have to be the same.
Okay? They have to be exact same monomials, right? Okay, I have one more slide that we must cover. So, I don't think you have to distribute that negative. Leave it as is. Okay. Domain. Who remembers what a domain is? No. It is the x value. Okay? It is the x value. So when I ask you the possible set of replacement values for a given variable, when I ask you to state the domain, what is x not allowed to be? Well, we have a golden rule in fractions. And in fractions, the golden rule is thou shalt not divide by 0. So what we need to do is first factor. When we factor, we can see all that the denominator contains. Once I factored it, I see there's an x in there and an x minus 4. What would give me a 0 in that denominator? Set them both equal to 0. X equals 0 and x minus 4 equals 0. What would make this statement give me a 0? 4, and here just 0, right? So first we figure out our domain at the point that we factor. Then it's asking us to also simplify. So what can be cross-canceled here? X, right. So now we are left with 5 over x minus 4. But the domain, here's how we write it. You should be writing this. X is such that x is an element of the reals. And x cannot equal 0 or 4. The thing to remember, when do we figure out domain? Right after when?
Graphic.
What? Graphing? Okay. When did I determine the domain? Right after what?
You set x.
Right after factoring. When you figure out what's in there. Okay? Right at the point here. Before you simplify, but after you factor. After you factor, but before you simplify. So on the next one, I can't just determine domain yet. I have to factor. Okay, what is x not allowed to equal?
0.
Or can't equal 3 here or a 0 here, right?
Yes.
Divide by 2, divide by 2. X cannot equal 0. That will give us a 0. So it's 0 and 3. So the domain is X is an element of the reals, but X cannot equal 0 and it cannot equal 3. Somebody said to me, does this mean that X always can't equal 0? No, it depends on what's in your denominator. When I factor the next one, what does it factor to? X minus 5, X plus 2, right? So in this case, what is X not allowed to be?
-2 and 5.
Negative 2 and 5. It's an element of the reals, but it can't equal negative 2 and 5. Do you understand?
Yes.
All right, sorry, that's the end of it.